Let's solve the following linear inequality. This is a linear inequation. That's because we have an inequality sign involved here, and also linear because if we look at the variable x, its highest degree is 1. So let us begin. So here we have x plus 1 divided by x plus 2. This is greater than or equals to 1. Now we have to be extremely careful here. We simply cannot cross multiply to write it as x plus 1 greater than or equals to x plus 2 because we do not know about the nature of x plus 2. That means this could be a positive number or it could be a negative number. So the safe bet will be that we'll keep x plus 1 over x plus 2 on the left hand side, but we'll transpose 1 from the right hand side to the left hand side. So that leaves us with 0 on the right hand side. Now we will combine these two terms. So we have x plus 2 in the denominator, and in the numerator we have x plus 1 minus x minus 2. So this is less than or equals to 0. Fine. So here we have x and x cancelling out. That leaves us with negative 1 divided by x plus 2. Now here there's a small thing that we need to be careful about. So here this is not going to be greater than or equals to 0, but only greater than 0. Now think about it. There is no such values of x for which this becomes exactly equals to 0. You cannot think of any number. So this is only possibility is that it is greater than 0. Now coming to our inequation, negative 1 divided by x plus 2 greater than 0. If we look at the numerator, our numerator is negative 1, which is a negative number. Negative number means it's less than 0. Right? So we have a negative number in the numerator and is divided by another number which is x plus 2, such that the result, or we can say such the quotient is a positive number. That is only possible if we consider the denominator to be also a negative number, because we know that negative divided by negative is going to give us a positive number. So this is the only possibility such that we have a value which is greater than 0. So that means our denominator x plus 2 must be less than 0. That means it must be negative. So solving for x, we have x is less than negative 2, and this is the solution to our given linear inequality. If we want to represent this solution in a graphical way, all we have to do is draw a number line. On the number line, we'll consider points 0 and negative 2. And here we have to consider all the values of x which is less than 2. That means to the left of negative 2, all the values of x. So that means it begins from negative infinity and goes up to 2. Here negative 2 is not included, so we'll put a bubble here or a simple hole, which means that our x equals to negative 2 value is not a part of our solution. So this is the graphical way, and the third way will be the interval form, which is also referred to as the solution set. So you can easily look at this graph and can say that our solution is going to start from negative infinity and goes all the way up to negative 2, and this is going to be an open interval because negative infinity is not bounded and negative 2 is not included. So these are the three ways of representing the solution to our given linear inequality. And to check the validity of the solution, all we can do is take numbers less than negative 2. So if we consider, let's say x equals to, let's say negative 3 for simplicity, and we'll plug this into a linear inequation. So we have negative 3 plus 1 divided by negative 3 plus 2, and we're saying that this value must be greater than 1. Let's see. So negative 3 plus 1, which is negative 2, divided by negative 3 plus 2, so that's going to be negative 1. Now we have negative 2 divided by negative 1, so that's positive 2. So we are getting a condition that 2 is greater than 1, which we know is true. So that means x equals to negative 3 is a part of a solution.